So I just made the table. So this will make more sense later, but as we talk about the tastes, there's three main taste cells: cell type 1, type 2, and type 3. You really only have to know this 1 through 5, okay? And that covers salty, sweet, umami, bitter, and sour taste. Fat, cold, and hot are not currently thought of as tastes. I think they will in 20 years. Fat's getting even more that way. They're not worked out as well. But the take home is that the salty taste has its own cell, a type 1 cell. The sweet, umami, and bitter taste are all type 2, and each cell is one of those based on the GPCR dimer that it presents, okay? And I'm gonna go through all of this. And then type 3 is detected by sour, and the mechanism with which that's detected has actually been a little hard to tease out, and I'll talk about why. And so after the lecture, look at this slide, see if it makes more sense. You'll see some similarities, right? So in the type 2 cells, the depolarization happens through increased calcium, and they end up releasing ATP, which causes signal transduction. Type 3 also causes increased calcium, but there the signal transduction is a lot like a neuron. It releases serotonin, okay? In addition, it actually also releases, it's been found as it releases serotonin, it releases about a third as much norepinephrine sometimes. And so that again has clinical manifestations if you're taking drugs that affect those. Okay, and so you'll see these proteins named TRP somethings. The TRP stands for transient receptor potential, and then it will be MP or V. Those letters are based off compounds that were initially found to bind these receptors. So the vanilla compound, vanilloid, is the V one. Interestingly, that one, even though it binds a receptor, is actually a kind of spicy receptor, so caspacin binds that one.